Good afternoon, grade 10 mathematics. Wow. Anyway, mathematics mindsetters. I hope you guys don't think it's a little weird that I'm here because I haven't been here since February. I know that is such a long time. So this is my first show here with myself, Megan, and of course my lovely leading lady, Natasha. How have you been?
I'm very well, thanks, Megan. Lovely to see you
Lovely
here for
to
the
meet
first
you.
time on a Monday.
What are we doing today?
All right, well, grade 10's mindsets, we are looking at mensuration, and when you see that word, don't get scared. All it really means is that we're looking at finding the total surface area and the volume of 3D shapes.
That's much easier to understand, because when I came in here, I was like, what are we doing? Because I had no idea. So it's volume and surface area. Don't get confused. I'm here to tell you that it's the second day of spring. As you can see, I brought a bit of spring to our fantastic show here at Learn Extra. Let me tell you what's happening. We have the exciting new spring school from the 23rd to the 27th of September. It's going to be packed with live shows, exam revision, presenters will be there, as well as our expert teachers. So we will be waiting for all your questions and of course all your comments, and you can catch us on Facebook, which is Learn Extra, and also on Twitter. So don't worry, don't stress, and I think we should get started on our mathematics Mondays.
All right, guys, so today we're looking at total surface area and volume, but before I get started, I have to say hi, big shout out to Aunt Molly and Douglas, who are watching at home, two special people. Not that you mindsetters aren't special, and you're so special, in fact, that we've dedicated a whole hour to you grade 10s. So today we're looking at, as I said, volume and total surface area. When you're looking at finding the volume and the total surface area, we're talking about solid shapes. And what is a solid shape? A solid shape is obviously not hollow, and it has 3 dimensions. All right? The formulae that I've put up on the screen, we've got volume is the area of the base times height, and total surface area is 2 times area of base plus perimeter of base times height. We will come back to that whole section. Okay, so when we're talking about volume and total surface area, I'm going to be using these 2 formulae, and we'll be looking at finding the total surface area and volume of what we call right prisms. Now, if you have a look at your screen, guys, you'll see this gorgeous picture of this beautiful object. And this, for some of you, you might know, like Megan knows, because she has seen it. This is the Louvre in Paris. And what it is this gorgeous glass pyramid, and it actually has a reflection, as you can see. This is just taken at night, so it has a reflection. But if you actually go to the Louvre, which is a museum in Paris, it's a reflective dome. So in other words, the dome, there's glass on the top, so the upright that you can see on your screen, and that below is actually an inverted pyramid. Absolutely beautiful. And with something like this, you can work out the total surface area, which would give you the amount of glass needed to make something like this. Okay, so maths is everywhere. All right. Some of the key concepts we'll be looking at today, and just some of the definitions that you guys need to know. A pyramid, that is a geometric solid, so a pyramid like similar to the one we saw on that side, and it has a polygon as its base and sides that converge at a point called the apex. Okay, so the apex is where all the sides sort of come together, right? So what that means is that the sides themselves are not perpendicular to the base. So if you have a look at what we saw just now, which was that triangular pyramid, the sides, okay, so I'm just drawing a rough idea of what the base would look like. The sides here were not perpendicular to the base. Obviously, we're looking at a 3D shape, right? And my 3D drawing is not very good. But the sides are not perpendicular to the base, all right? The triangular pyramid and the square pyramid obviously take their names from the shape of the base, and we call a pyramid a right pyramid. A right pyramid as opposed to a wrong pyramid. A right pyramid if the line between the apex, which is, remember, the point where all the sides converge, and the center of the base is perpendicular to the base. So if the line between the apex and the center of the base is perpendicular to the base, it's called a right pyramid. What am I talking about? I've drawn a picture for you here. If you have a look, this is now a cone, which we're going to discuss just now, but you see that the apex, the point where everything meets, at the cone. Okay, that's your apex. And if you follow that line right down to the base, you'll see that that line, that height, is perpendicular to the base. So when you have a structure like that where the line that joins the apex to the center of the base is perpendicular, we call this a right pyramid. Okay, so this is a right pyramid. Right coming from right angle. Okay. Now going back to this shape that we've got, a cone. All right, a cone, obviously, if you invert it, it's going to look like an ice cream cone. This one is laying on its base. It's similar to a pyramid, except that the base is a circle. Okay, so instead of a polygon, remember a polygon has more than 4 sides. So instead of it being a polygon, your base here is actually circular. All right? Then spheres. Now, the easiest way, I think, to remember a sphere or to think of a sphere is, you know, lots of you guys like those little sweets called astros. If you look at an astro, that's a perfect example of a sphere. If you cut it open, you get 2 identical halves. Okay? So spheres are solids that are perfectly round and look the same from any direction. Okay? Now, it's interesting to know all that stuff about pyramids and cones and all of that, but most of our work today, the most common part of this section comes from working with right prisms. Okay, so don't get confused. We were talking about pyramids, now we're talking about prisms. So what is the difference? Well, a right prism is a geometric solid that has a polygon as its base, and the vertical sides are perpendicular to the base. Big difference there. So here the vertical sides have to be perpendicular to the base. So for example, the easiest one we can think of, so rectangular prism. All right, so something like that. And if you have a look at a shape like that, you would see that if the base is a polygon, remember more than 4 sides, in this case rectangular, all the vertical sides are actually perpendicular to the base. So no matter which way you look at it, all of the vertical sides would be perpendicular. And if you draw one going down there, that one would also be perpendicular to the base. Okay? Importantly, the base and the top of the surface are exactly the same shape. So if you were to unfold a rectangular prism, right, if the base is rectangular, the top is going to be the reflection of that. Both are going to be exactly the same. Okay, and it is called a right prism because the angles between the base and the sides are right angles, as I mentioned already. Now, in a triangular prism, we have a triangle as the base, and obviously a rectangular prism will have a rectangle as its base, and a cube, most of you will recognize, it's sort of like a dice. So with a cube, it's a rectangular prism with all the sides of equal length, in other words, a square base. And a cylinder is obviously a type of right prism which has a circular base. And we'll be looking a lot at these cylinders today when we discuss volume and surface area. So this is a right prism with a circle as its base. All right. So what exactly is volume? We're going to be talking a lot about volume. We're going to be talking a lot about total surface area. What is the difference between the two? Hopefully you'll understand all of that by the end of the show, but we're going to kick things off with just looking at the volume. All right? So volume is the space that is occupied by an object or the contents of an object. So for example, if you think about a can of cool drink, okay, the amount that that cool drink can hold, so 200 mLs of your favorite cool drink. That 200 mLs actually describes the volume, so the amount of liquid that that container can hold. All right? And it is measured in cubic units. Now, guys, the way you work out the volume, and it's important that you have this formula and you know how to use it. It will not be given to you, so you need to know it. The volume is equal to the area of the base times the height of the shape. Okay, so volume is area of base times height. Remember this formula. Okay. The best way to remember is to obviously practice, right? So with our first question for today, we are asked to find the volume of this rectangular prism. Okay, remember it's rectangular, which means the base of this shape is a rectangle. That's why it's called a rectangular prism. If it was a circular base, it would be called a cylinder. If it was a square base, it would be called a cube. All right. So we've got this rectangular prism, and we want to find how much of stuff can we put in there. So what is the volume? We are given units in centimeters. So obviously when we find our volume, the overall answer is going to be in cubic centimeters. Okay. So using our formula, we know that volume is equal to area of the base times the height of the shape. Now, because we're dealing with a rectangular prism, we see that the base is obviously what the shape is sitting on. If we just highlight the base and have a look at the base. See, let's just undo that. All right, so if we have a look at the base, which is that, the flat surface, right? Now that's a rectangle. We see that the length is 7 centimeters and the breadth is 6 centimeters. So we've identified our base as the rectangle with length of 7 centimeters, breadth of 7 centimeters. How do we find the area of a rectangle? Well, we know that the area of a rectangle is equal to length times breadth. All right. We are also given that the height of this shape is 10 centimeters. So now if I put this information into this formula for volume, which is area of base times height, it's going to become the area of the base, which is length times breadth times height. So it's going to be L times B times H. We know that the length is 7, so we can plug that in. We know that the breadth is 6, and we know that the height is 10. We can then multiply all of that together. 7 times 6 is 42, and 42 times 10 would give us 420 centimeters cubed. Okay, it's important to indicate the cube because the cube tells you that you have actually worked out the volume. All right, so nice and easy to get things going, hey? Hopefully you all understand so far. You understand the difference between right prisms and right pyramids. And if you have any questions, let us know. But I think it's a good spot to maybe go for a quick break, Megan.
Quick break, Tash. Okay, no problem. Well, like we said, we'll see you straight after the break. Welcome back, grade 10s. Hope you had a good break. Stretch those little arms because you must get writing down because this is fantastic, fantastic revision. I'm just telling you that these things, volume and surface area is it's a very important segment in your papers. So get listening and get learning with Tash. Let's go.
All right, guys, so we were looking at finding the volume before the break. We looked at finding the volume of a rectangular prism. I'm going to go straight into total surface area, but just to remind you that when you're finding the volume, you always find the base of the shape, and then you say, find the area of the base, and then you multiply that by the height of the shape. Okay, so that's standard if you want to find the volume of a right prism. Okay. Now we're going to go into question 2, which is about surface area. Just a reminder of the formula and how we use total surface area. Also, guys, I just want to remind you that I'm using the formulae to work out total surface area and volume. But as I'll show you in this question, what you can actually do, and some people do prefer to do it that way, although personally I don't like doing it that way, is they undo the shape or sort of unwrap the shape, and we call that a net. So what they'll do, as I'll show you in this example, is they'll break it up. So for example, a cylinder is made up of 2 circles and a rectangle, and they'll break it up and then find the areas of each and then add them together. So if you like doing it that way, you're used to doing it that way, then please continue to do it that way. But if you'd like to learn something new and personally, I think an easier way to work things out when it comes to total surface area and volume, then today's show will be really good for you. All right, so here we are asked to find the amount of material needed to cover the cylinder below. Now, guys, as soon as they say you're going to cover something, so that's, we're always talking about the outside area. We're talking about finding the total surface area. Okay, so we're talking, so if you think about putting a wrapper around this entire cylinder, then that's what we're doing. We're finding the amount of material that we need to cover the cylinder below. Okay. Now, you can see in the drawing that they've given you the height of the shape is 10 centimeters, and they've given you the radius of the circle at the bottom of the cylinder is 5 centimeters. And they want you to find the amount of material. So in other words, you need to work out the total surface area. The one way you can do it, guys, so this is method 1, is you can unpack the cylinder and you can say, okay, well, I know that a cylinder is made up of, okay, so if this is my cylinder, we know that it's made up of a circle at the bottom, a circle at the top, so that's going to be 2 circles. There's the one circle, there's the other. And then the part in between that the circles wrap around, all right, that is going to be a rectangular shape. So you break it down and you see, okay, we call this a net, as I was saying before. This breaking up of the cylinder into its individual portions, that's called a net. So we make 2 little circles and we make a rectangle, and if we put it all together, we would get a cylinder. What you could do is you could then find the area of the individual circles, and then you could add that to the area of the rectangle. And then you'd add those together and you'll get your total surface area. So that's method 1. That's the common way that a lot of people are shown to do it. So if you're happy with that way and you know how to do it, then go for it. Okay, I want to show you a different way to do it. So this is using the total surface area formula that I showed you in the beginning. And this is method 2. Now these formulae, they only work for right prisms. Okay, if you're wondering what a right prism is, please refer to the notes that we have given you. So this works for a right prism. The total surface area is equal to 2 times the area of the base plus the perimeter of the base times the height. So if you've got a good memory and you can take the time to learn this the formula, then please do so. Total surface area is 2 times the area of the base plus the perimeter of the base times the height. But the one thing you've got to be careful with here is this is for a closed shape. Okay. Now imagine what happens is if you have, for example, a cylinder, like we've got there, but the top of this doesn't need to be covered. So this is going to be open. So we don't need any material there. We just want that to be a hollow. Okay? So if you want that to be a hollow and we're just covering the everything else, right? We're not going to have 2 bases because this formula, I keep saying formulae, but there's just one formula here. This formula is derived from breaking this cylinder or whatever right prism you have, breaking it up. So that's where it comes from. But obviously, if you're going to have a cylinder with an opened top, all right, so there's nothing on the top there, you don't need any material to cover the top, then you've got to drop the 2. Because there's no longer going to be any material needed for the top portion. Okay, then what happens is you drop the 2, and for an open shape, very simple. Once you know the first one for an open shape, all you do is you drop the 2 and your total surface area just becomes area of the base, because as I said, there's just one base now, plus perimeter of the base times the height. Okay. All right, so that's all you need to remember with this one. That's the only way you've got to be careful is, are you dealing with an open shape or are you dealing with a closed shape? So in this case, we are given a closed shape, so we're going to use 2 times the area of the base plus perimeter of the base times the height. Now remember, we identified here that the base was actually a circle and the radius was 5. So they told you that the radius was 5. They also then gave you in the diagram that the height of the shape was 10 centimeters. Okay, so this is our prism, our cylinder, and the height of this is 10, and the radius of the base is 7. This is all in centimeters. Okay, so using my formula, I'm going to say total surface area is equal to 2 times the area of the base. And this is when it's important for you guys to remember your formulae, because now we're dealing with the circle. What is the formula for the area of a circle? Well, the area, let's see if we can get a circular shape in here. The area of a circle is equal to pi r squared. All right, hopefully you all know that by now. And the perimeter of the circle, or in other words, the circumference of the circle, so the perimeter, remember perimeter, you're talking about the outside edge. The perimeter of the circle is 2 pi r. 2 times the radius is also the diameter, so you could say the perimeter or the circumference is 2 pi r, or pi times the diameter. Guys, and I must stress and just remind you guys that these formulae will not be given to you. You need to remember it. So you need to, by this stage, already know what the area of a circle is, the area of a triangle, rectangle, all of those common shapes, and you need to know how to find the perimeter of each of them. Okay. All right. So we know that area is pi r squared. We know that perimeter is 2 pi r. So now I can use my formula and say total surface area is 2 times the area of the base. So it's going to be 2 times area of a circle is pi r squared plus the perimeter of the base, which is going to be 2 pi r. And then we times that by the height. Okay. So it's just now a matter of plugging in. It's going to be 2 pi times r squared, so that's going to be 5 squared, plus 2 pi times your radius, which is 5, times the height of the shape, which is 10. Okay. So this is going to give me 5 squared is 25, 25 times 2, 50 pi, plus 2 times 5 is 10. 10 times 10 is 100, so 100 pi. Add them together and you get 150 pi, which you can then work out on your calculator. So it's 150 times pi, and that gives us 471,24. So that's 471,24, and here we're dealing with area, so it's going to be centimeters squared. All right. Okay, so that's the total area for the cylinder. Okay, so importantly, you need to remember that if you have actually opened the shapes before, unwrapped them, and then found the area of each of the individual components and added that together, you should get exactly the same answer as if you were using the formula. Okay, so either method is perfectly acceptable. All right, I'm quickly going to check if there's any questions before we go on to the next question for today. Megan?
Daniel actually gave an answer for question 2. I just didn't want to interrupt you. He said the answer is 50 centimeters for power 2 for question 2.
50?
Yeah, 50 there. I think there, that 50 pi. I think it was over there.
Oh, this part?
Yes, he just gave us the answer, but there's no questions.
All right, great. Well, I'm glad that
great.
he's following. Fantastic. All right. Okay, guys, so this is a section that is not a massive section in your exam. You will get a couple of questions, but it's not a massive section. But you do want to learn these formulae so that when you approach the section, you can get full marks, because it is a section that you can get all the marks for if you know the formula for area, the formula for perimeter, and while you're at it, you might as well learn the formula for total surface area, and then obviously use your formula for volume as well. All right, so continuing now with the total surface area and volume theme, this is now question 3, slightly different. Here they tell you that a cylinder has a surface area of 48 pi centimeters squared, and they tell you the diameter is 6. They then ask you to find the height of the cylinder. So let's have a look at what's going on. So we've got, once again, a cylinder. All right. There we go. And they tell you that the surface area, so the total surface area, is equal to 48 times pi. And they tell you the diameter, very important, is 6. So that length there, D, is equal to 6. They ask you to find the height of the cylinder. Now, the way we unpack this is we look at the information we've been given. We've been given a value for the total surface area. We've also been given the length of the diameter, and we're asked to find the height. So we need to use the given information to try and work backwards. How do we work backwards? Again, I'm using the formula. I just showed you that total surface area is 2 times the area of the base. Here our base is a circle, so it's going to be 2 times pi r squared, plus the perimeter of the base, which is 2 pi r, and then we times that by the height of the shape. Okay, which in this case we don't know, because that's what they're asking us to find. All right. Now that's how we would normally find, that's the expression for the total surface area. Okay. They've also told you that the total surface area is 48 pi. So if you know that the total surface area is 48 pi, and you know the expression for the total surface area, you can equate those, because these are equivalent formulae. Right, so I can say 2 pi r squared plus 2 pi rh is equal to 48 pi. All right, we know what the radius is, and here you've got to be careful, because remember, they didn't give you the radius, they gave you the diameter is equal to 6. So if you want the radius, you need to divide by 2. So that's a little catch there. Hey, if you put the 6 in, you are going to get something that's going to give you strange answers. Okay, so be careful with that. If they gave you the diameter, you need to divide by 2 to get your radius. Okay, so the radius, we take the diameter, which is 6, we divide it by 2, and we get an answer of 3. All right, this is going to become 2 pi times 3 squared plus 2 pi times 3 times h is equal to 48 pi. And guys, you'll see the only unknown value, the only variable here is h, because remember, pi is not a variable. Pi has a value. So the only unknown value here is h. Okay? You can also see that pi is a constant in the entire equation. So we can divide the pi out. So we can divide the whole equation by pi. So we divide the left-hand side by pi. We divide the right-hand side by pi. And we're going to get 3 squared, which is 9 times 2 is 18, plus 6h is equal to 48. Because remember, I've divided the pi out. So I'm going to get 6h is equal to 48 minus 18. And that's going to give me 8 minus 8 is 0, 4 minus 1 is 3, so that's going to give me 30. So 6h is equal to 30. I'm just looking for h, so I divide both sides by 6, and I get that the height, 30 divided by 6, is 5 centimeters. All right. Okay, so I just want to go through what we've done here to get to the height. Okay, they told you, remember they gave you that the total surface area was 48 pi. They gave you the diameter so we could find the radius by dividing by 2. And then to work out the height of the cylinder, we knew that the formula for total surface area was worked out as 2 pi r squared plus 2 pi r times height in this question. We simply then substituted the value of the radius in, and we equated that to the total surface area that they gave us, and we were then able to solve for the height. Okay. Once we've got the height, we have to have the height because the next part says find the volume correct to 1 decimal place. So if we don't know the height of the shape, we're not going to be able to do part B. All right, so let's have a look at part B. Okay, so we know that the height is now 5 centimeters. We're looking at the volume. We know that the volume is area of the base times height. Okay, remember once again, I keep saying the same thing over and over again in this question, but the base is circular, so therefore area of base pi r squared times the height will give us the volume. So it's going to be pi, and you see that we just worked out from above the height is 5, and we know that the radius was 3. So we can put in the radius is 3 squared times the height, which is 5. So we're going to get 9. 9 times 5 is 45 pi. And we can see what that gives us by using our calculator. So it's 45 times pi, and that gives us 141,37.
Natasha, can I ask you a question?
Yes, please do.
Daniel asks, is it possible to get the same volume when the cylinder's oblique?
Yeah, guys, remember, we are only looking at right prisms. So you can't get the same. Oblique is a completely different thing.
Yeah.
It's not, remember, this whole section, as I said right at the beginning, we're just dealing with right prisms. In a right prism, we have the sides being perpendicular to the base, and the top and the base are exactly the same shapes. Okay, so with an oblique base, you'd have to use other formulae, because remember, when he's talking about oblique, guys, let me just show you, for example, something like this. It's not quite a circle, it's more oblique, okay, or oval shaped, okay. For that, you're going to have different formulae. And a lot of you, well, I know all of you in grade 10 won't know how to work out the area of an oblique shape. So you're not going to be asked that kind of question unless they explicitly give you the formula to work out the area of such a shape, okay? Because the formulae are different from those of circles. Okay, so you can't introduce that. Yeah.
Thanks, Dan.
All right. Okay, so we've got our area. We now have our height, and we've got our volume. So I think this is a good spot to take a break.
Good time? Okay, cool. Well, mindsetters, well, we've learned a lot about volume and surface area, but we have to take a break. So we'll see you right after. Welcome back, grade 10s. You are watching Mathematical Monday here on Learn Extra Live. So I hope you've tuned in, or if you've just tuned in, welcome, welcome, welcome. I just want to say hello from me, and of course give a shout out to one of my best friends, Blake Stead. I'll see you soon. So it's all from me. Over to Natasha with our volume and surface area.
All right, Megan, I think you had some questions for us there as well from the mindset.
Yes. Okay, well, in the break we were talking about this. So now it says, Lebogang says, excuse me, the height is actually 2 on question 3.
Lebogang, I think if you have a look at the question, so this is the question 3, the one that we've just done, and the mistake you might have done is you maybe didn't divide the diameter, which they gave you was 6. Maybe you didn't divide that by 2 to get a radius of 3. I've had a look at all the working and can't see any mistakes here. We eventually get to 6h. 6 times the height is 30, divided by 6. 30 divided by 6 is 5. It's definitely no mistake with the heights, but as I say, common mistake that a lot of pupils would have made with this question is they would have forgotten to divide the diameter by 2 to get the length of the radius. All right, and there were
another one.
more.
Kaklejo Makwele says, which formula do we use if the other base of the cylinder is not there?
All right, okay, so it's a good question, and it's one I discussed in question 3 as well, and I'm going to go through it quickly again before we get on to question 4. If you're looking at an open shape, so as he said, where there's no top, okay, so an open shape, uncovered shape. So if we're looking at a cylinder, which was the last question, and you have that the top part here is actually missing. So you need to cover this shape, but there's no top, so you're not going to waste any material on the top part there. Then your total surface area formula becomes area of the base plus perimeter of the base times the height. Okay, so importantly what you'll notice is that the 2 that we had in the original formula is not here anymore. Okay, we take the 2 off for obvious reasons. If we are dealing with a closed shape, we've got 2 of the same shapes at the bottom of the shape and at the top. So then we say 2 times area of the base, but obviously if you're dealing with an open shape, you don't have the top portion, so you simply drop the 2 from the formula and it just becomes area of base plus perimeter of base times height. So nice question there.
And the last one is Impulse says, is surface area the same as total surface area?
Surface area, total surface area, we use them interchangeably, it's the same thing.
Okay, yeah.
Right.
No, that's
Great, okay. Well, I'm glad that you guys are following and you're keeping us on our toes, asking questions, all of that. Very, very nice. Okay, let's have a look at question 4. Now here, guys, what we're going to look at is what happens when we multiply one or more of the dimensions. Remember, dimension is just another way to say the length or the length of a side. What happens when we multiply one or more dimensions by a factor? Okay. What happens to the volume? What happens to the surface area? Now, obviously, as you're going to see, is when one or more of the dimensions of a prism or a cylinder is multiplied by a constant, the surface area and the volume will change. So we're still dealing with right prisms, okay? And if you're going to multiply by a constant, then the surface area and the volume will change. Okay, so let's have a look at a question. They say that the dimensions of a rectangular prism are length, breadth, and height, and the volume is V. Okay. Then part A says, find the volume V1 in terms of V if one of the dimensions of the prism is multiplied by a half. So firstly, let's draw what we've got. Okay. So we've got a rectangular prism, as they said. All right. There we go. That's my best impression of a rectangular prism. And they tell you that the base has length and then breadth and height. Okay. My shape keeps moving around, so I'm going to just quickly undo that. There we go, that's better. Okay, so if we're looking at our base, we're going to say that's going to be the length, that's going to be the breadth, and then the height of your shape is going to be the other one going in the other direction, so that one there. Okay, guys, an important thing, because what I've just drawn there, you can see that I've said the base is length, breadth, but I'm showing you the side of the rectangular shape. Now, if you're working out volume, total surface area, or anything like that, and you're looking at a solid shape, all right, and we're talking about right prisms here, if you use, in this case, a rectangular prism, if you use any side as your length and breadth. You can really use any side. Because remember, if you're looking at a rectangular prism, you can literally think of a box. You can turn it around. The base is going to change all the time. But just because a different surface is sitting on your table or your floor, it doesn't mean that the volume is going to change every time the box flips around. Okay, remember that. So that means if you use the side portion as the length and the breadth, then the other portion, the one you left out, is going to be your height. Okay, so the other dimension is going to be your height. So you can literally use any of these rectangular sides as your base, as long as you remember, if you're looking at the side, then your height is going to be that one, or if you're looking at the base, then your height is going to be going vertically up. All right, that will not change the volume of the shape. Okay. All right, so we've got the length, the breadth, and the height, and we need to see what happens when we multiply just one of the dimensions by a half. So it doesn't matter which one. Let's just say the length is decreased by a half. Okay, so our volume would normally be area of the base times the height. Here our base is actually a rectangle, and we know the area of a rectangle is length times breadth, and the height is just h. That's the original shape. Now what they've done is they've taken one of these and they've said you are now going to multiply one of those dimensions by a half. So either we're going to have a half L or a half B or a half times h. It doesn't matter, as you're going to see. It doesn't matter which one is multiplied by a half. Look at what happens to the volume. So this is part A. The volume is going to become, so let's just say it was the length that was multiplied by a half. So the length is now going to become a half times the original length times breadth times height. So this is going to become a half length times breadth times height. So the volume itself has halved. It doesn't matter which of these, which factors were multiplied by a half, because remember, when you're dealing with multiplication, multiplication is commutative, which means you can swap them around. 2 times 3 is the same thing as 3 times 2. So it doesn't matter where the half is. Ultimately, what's going to happen is if one of the dimensions is halved, then your volume overall is going to be a half of the original volume. Okay. All right, so that's if one of the dimensions is changed. Now, part B says find the volume V2 if two of the dimensions are multiplied by a half. Okay, so let's just finish off part 1. So A, our original is V. So V1, which is the new volume, was a half V. Now, part 2, or part B, here we're looking for V2. Remember, your original volume was with nothing happening. The shape was just length times breadth times height. Now in part 2, they're saying 2 of the sides are being changed. So it's either going to be a half length or a half breadth, or maybe they changed, maybe they did a half of the height, and they changed a half of the length. It doesn't matter. Any two of them can be halved, right? So what's going to happen? So my length is now a half of the original length. My breadth is a half of the original breadth, and the height stays the same. Okay, so this is the second volume. We're going to get a half times a half is a quarter length times breadth times height. Okay, remember length, breadth, height, that was the original volume V. So your new volume V2 is going to be a quarter of the original volume, and this is when you change 2 dimensions. So we changed 2 dimensions, or in other words, we multiplied 2 of the dimensions by a factor. Okay, so when we multiplied 2 dimensions by the factor, the volume was that factor. So if we call the factor K, it's going to be k squared times the original volume. All right. And then the last part of this, part C, they say find the volume V3 if 3 of the dimensions are multiplied by a half. So now they're changing the length, the breadth, and the height of the original shape. So V3, the new length is a half the original. The new breadth is a half the original. And then the new height is a half of the original height. So the new volume, a half times a half times half, is going to be an eighth of the original volume. Okay, so this is going to be an eighth of the original volume V. So when we changed, so this was when we changed 3 dimensions, we multiplied 3 dimensions by a factor. So 3 dimensions you multiplied by some factor. Then your new volume was k cubed times the original volume. Okay. All right. So let's go through each of these and let's just make the points in each of them. What happened to the new volumes versus the old volume when we compare them? Okay. So in the first one, we looked at multiplying just one of the dimensions by a factor. In this case, it was a factor of a half, but it could be anything. It could be a factor of 2, 3, 4. It doesn't have to be fractional. So we say if we multiply one of the dimensions by a factor k, right, then the new volume is going to be just k times the old volume. All right. If we change 2 dimensions, so if we said 2 of the dimensions, we changed the length and the breadth, so we multiplied by a factor of k, but now we're timesing 2 of the dimensions by k. We saw that the new volume was k squared times the original volume. And then when we multiplied 3 dimensions by a factor of k, then the new volume was k cubed times the original volume. All right, so hopefully you guys can see what's happening there. If you just change one dimension, your overall volume changes by a factor of k. If you're going to multiply 2 dimensions, it changes by k squared, and then 3 dimensions, it's going to change by k cubed. All right, before we look at an example with a few numbers, I'm just going to change some of this, put some numbers in. Let's see if you guys are following.
I wanted to say, Ufile says, I have a problem when we determine the volume and area. But now, Ophelia, what is your problem? We've just been going through it all, so if you can just post exactly what and how what you're struggling with, actually, then we will be able to help you. And, okay, you just went through question 4, Sekle wanted you to, and then we're going back to question 3. How do you make the height to be the subject of the formula in question 3?
All right, well, I'm going to show you just generally how you would change the subject of the formula, but again, that's a section that you would have done at the beginning of the year, so possibly by this time of the year, some of you are a bit rusty. In that question, let's have a look. Let's go back to question 3. Okay, and here we were dealing with the total surface area, and then the height was part of the total surface area equation. This was just a normal linear equation, so I actually didn't have to change the subject of the formula really, because this was just a straightforward linear equation. It's like if you had 18 plus 6x is equal to 48. It's just, I know sometimes students get confused when you replace the x with an h and then they think, oh, what do you do? But it's exactly the same thing. This is just a straightforward linear equation. So the way I got to the h is I took all the numbers to the one side, so I took all my numbers to the right-hand side, and then isolated the h by dividing both sides by the 6. But guys, so this is just a straightforward linear, but what I want to show you is when you're dealing with something like a formula like volume, and you've got volume is length times breadth times height, and you know that that's equal to some value. Let's say you've asked to find something and you've got that the volume is 40 and you've been asked to find the length, okay, in terms of B and H. Now, all you do is you isolate. You say, well, how is the length, or what is the length attached to? So if I'm solving for L, I see that it's attached to the B and the H by multiplication. So you need to undo that process by doing the inverse of it, or the opposite of that. So if it's joined by multiplication, to get rid of it, the B and the H, I need to divide it out. So you look and you have a look and say, how is it attached to what I want? And then how do I get rid of that? So the B and the H is attached to the L by multiplication, so you need to do the opposite operation, which means or the inverse operation, which is division. So therefore, if you divide by B and H, you get L is 40 over BH. Okay, so unfortunately that takes us to the end and it doesn't give me time to go back and show you what happens when we change factors with numbers, but hopefully overall you guys are understanding better how to work with volume and surface area, and you now know how to use the formulae to help you with those questions.
Thank you, Tash. Thank you, Grade 10 Mindsetters, for a great show. I didn't have time to mention Stars in Education. Go look at the page, facebook.com/learn extra. That's all from me to you. Same time, same place next week. Bye.